Hi, in this video we'll be finding curl and divergence of a vector field f. So our case, f will be x squared y, x y z, then negative x squared y squared. So to find curl, quick refresher, curl of f equals the del operator crossed with a vector field, or you can write this as ry minus qz pz minus rx qx minus py. So a little bit on this kind of notation. This is where we designate the vector field as p, q, r, and then we call, well, we know nabla equals this and this. Right? So a kind of quicker way, little trick is to rewrite this del cross f as this ry minus qz, etc., 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 by denoting each component in the vector field as pqr. So this is a quick way to find the curl, and for us it equals, I recommend you try this on your own as well. This, and then pz, this is 2x y squared, and then last component is zy minus x squared. Right? Okay, so I guess make sure that you can do that. It's pretty straightforward. For our divergence of f, it's sometimes written as this in a homework problem. This is the same del operator dotted with the vector field. This time it's dotted, not crossed, so it's a little easier. And using this same notation up here as pqr, we know this dot combined with the del operator, so this dot this, we can just rewrite this as dp partial p respect to x, this pq respect to y, and p, right, partial r with respect to z. Oops, right here. So this is pretty easy as well. So p, this will just be 2xy plus q with respect to y. So in this case y is a constant, right? This is what a partial derivative is, and then that's just xz, and then r, there's no z, so that's just a big constant, and that is 0. So this equals, I guess, div f. So this is a vector. If we do the curl, we get another vector field, and if we do the divergence, we get a function, a scalar function. So they might test you on that in a test. Does curl of the vector field give you a vector or a scalar function? And it gives you a vector field. So another quick kind of property or tidbit about curl and divergence is that the divergence of curl is always 0. So if we say this fact, answer this question: is f conservative? If curl of f equals 0, then f is conservative. This is a fact. There's probably a rigorous proof out there somewhere, but I guess just remember that. And since ours is clearly not equal to 0, our vector field is not conservative. And back to the quick tidbit, divergence of curl is always 0. Divergence of curl f always equals 0. That's just good to know. So yeah, you can look this up and you'll be able to see it. And actually, I'll just show you. So our curl, we have a vector field, a new one. This is different from the above one. We have z squared y, xy, then yz. We have this vector field, right? And then if we do the curl, curl f, we get z 2yz, then y minus z squared, right? And then if we do the divergence of this, so div of this curl, so this means we do the partial p, partial x, partial q, partial y, partial r, z. Sorry, got a little scrunched. And then this, so p, q, r, p with respect to x is 0, plus q with respect to y is just right, 2z. Then this is minus 2z, and so this equals 0. So that's a neat property of divergence of the curl. Thank you. Actually, this should be the 0 vector.